So we've studied this year. Like when you multiply with the same base, you add the exponents. Like that rule. Everything's a little tougher when the exponents are rational exponents. That means when the exponents are fractions. Fractions are rational numbers. So the same principle applies. So the bases are the same. The base is 7, so the base is still 7. And I just like here, I'm going to add the two exponents together. So it's going to be 2/3. In the exponent spot, it's 2/3 plus 4/3, which actually goes together nicely. That's 7 to the 6/3, which is 7 squared. So that's the property there. Let's try this one. You know the property power you multiply. So we're going to multiply the exponents. So we're going to multiply. Well, actually, that one's not too bad, 2 to the 6th, because I didn't have exponents there. If it was something like 3 to the 1/2 to the 1/4, it would be 3 to the 1/8, right? Because you're multiplying 1/2 times 1/4, which is 1/8. Okay, when you have multiplication inside of the parentheses there, you can break it up into two separate ones. So I could write this as, if I want to, as 3 to the 1/2 times 9 to the 1/2. And we know that that's really what? As a radical, that's second root first power, so that's square root of 3, times radical second root first power. So that ends up being 3, because that's the square root of 9 is 3, times square root of 3, because those are being multiplied. Okay, so this one with a fractional exponent, again, the idea of this is a reciprocal power when you have a negative, so it brings it down to the denominator. So same thing here, this would be 1/8 to the 1/3 power, which of course is 1/, that's really the third root of 8 to the first. If you think about it, it'd kind of be nice to simplify this, right? We don't like radicals in the denominator. So maybe if I could get that denominator to be cube root of, actually, you know what? I didn't see this before. Sorry, 1 cube root of 8. What is the cube root of 8? You don't have to do all that work. Cube root of 8 is 2, which is rational, so we don't have to rationalize the denominator. And this one, the rule is with division, you subtract the exponent. So same thing here. The bases are the same, so the base is 5. We're going to subtract the exponent, so 3/2 minus 1/2, which is 5 to the 2/2, which is 5 to the first, or 5. And last one. So the rule is with division, you can break it up into two separate ones. So this would be 7 to the 1/3 power divided by 8 to the 1/3 power. And that could be simplified. That's really the cube root of 8 and the cube root of 7, which is really cube root of 7 over 2. Should be a little tiny 3 in there. I made that 3 a little big there. That's the idea. Okay, when you have stuff like this is not a prime number. So right away, I'm going to go to, menu 2/3, factor 216. Ah, so much better, right? Because I'm looking for, now I can write that. I'm just going to write it like that. So I'm going to write 2 to the 3rd times 3 to the 3rd. This is still being put to the 1/3 power. Now let's do power. According to the rule, we have to multiply that by both terms, right? Because there's a multiplication sign in between here. So 2 to the 3/3, which is 2. 3 to the 3/3, which is 3, which is 6. Wow, simplifies nicely. Okay, this one, 5. So the rule is you're going to add the exponents. So 5 to the 1/2 plus 1/2, which is 5 to the first. 1/2 plus 1/2 is 1. So the bases are not the same, but 3 is a prime number, but 27 is not. So if you go to your menu 2, 3, 27, that's 3 to the third. So this is really 3 to the 1/4 times 3 to the third to the 1/4. So this is 3 to the 1/4 times 3 to the 3/4. You're going to add the exponents, so this would be 3 to the 4/4, which is 1. So the answer is 3. This one again, the bases are not the same, so I'm not. Hopefully that'll simplify a little. So menu 2, 3, 2 squared times 3. So that's going to be a little bit simpler. So this is 3 to the 1/2 times 2 squared times 3 to the 1/2. 1/2 power is really square root, so this is square root of 3 times 2 squared to the 1/2 is 2 to the 2 times 1/2 is 1, so that's times 2. And 3 to the 1/2 is really square root of 3. Square root of 3 times square root of 3 is 3, so 2 times 3, which is, or 2 times square root of 9, which is 6. Well, these exponent rules get really tricky, especially when you add fractions to them, so it is a little bit tough. Many times on a tough problem, it's going to be really helpful to convert to rational exponent form. So let's make, instead of writing it in radical form like it is now, let's just start by converting it. So this would be x to the, I guess that would be 3/4 over x to the 2/8, which I really want the same denominator there. So same. So I'm going to write this x to the 3/4. I'm just going to simplify this a little bit. Let's say that's x to the 1/4 there. Now I'm going to use my exponent rule. That's x to the 3/4 minus 1/4, which is x to the 2/4, which is x to the 1/2, which is square root of x. Again, the root is there. The index is going to be 2 there. This one is going to be helpful with the decimal. Go ahead and write it as an improper fraction. We really prefer that. So 16 to the 5/2. The other thing I would think about doing is simplifying anything that's not a prime number. Go and simplify it, right? So menu 2, 3 of 16 is 2 to the 4th. So I've got 2 to the 4th to the 5/2. So you're going to multiply power power. So this would be 2 to the 20/2, which is 10. And I would just write, unless you have a calculator that you're allowed to use a calculator, that would be the answer there. So this one's a little tougher. You can do this. You could, it might help you to write it in radical form. So this would be the third root of -8 all to the second power. So let's do that in 2 steps. Cube root of -8 is -2. -2 squared is +4. Again, I'm thinking it's going to help to rewrite this. It's not a prime number. I just knew cube root of negative. I didn't have to write that as -2 to the third because I knew cube root of -8 is pretty easy. So this one, if you don't know it, let's just write it as prime factored form. So this would be 2 to the 4th power, 2 times 2 times 2 times 2, to the -3/4. If you use power power, you're multiplying 4 times -3/4, which is -12/4, which is -3. And let's go ahead and do that. That would be 1 over 2 to the 3rd, which is 1/8. And finally, a couple more here. If you don't know the prime factorization of 32, it's not a prime number. So let's do that in the calculator. 32 to the 5th. So if I write that as, wow, that's so much easier now. To the 3/5 to 3 there. So it'd be 15/5, which is 3, so 2 to the 3rd, which is 8. And this one, so 27 is not a prime number, so I'm going to go menu 2, 3, if you don't already know it, 3/3. So this is 3 to the third to the negative 2/3. So we get 3 to the negative 2, or negative 6/3, which is negative 2, which is 1 over 3 squared, which is 1/9. And a few more problems here. These get, again, kind of complicated because we're dealing with fractions. Because there's multiplication inside of there, we can distribute. But I also might think about simplifying that 16. So if you do prime factored form, that'd be 16 to the fourth. So we'll write this as, this first number is going to be 2 to the fourth to the power of negative 3/4 times y to the negative 8 to the power of negative 3/4. Simplify that a little bit, so that'd be 2 to the negative 3 times y to the positive 23 over 4/6, which is 1 over, say, 2 to the third, which is y to the 6th divided by 8. Convert to rational exponent. Anytime it's kind of tough, it's not a bad idea to convert it. So this would be, or just the problem might say, just convert this to rational exponent form. So I need this is going to be 3x to the power of 3x to the third to the power of, this is essentially the 1/2 power. Remember, square roots are like, 1/2 power. And so you could write this as 3 to, you could write it like that, or 3 to the 1/2 times x to the 3/2. This one, it says to convert to radical form, so you're just going to make that a radical. So this is going to be 7th root of x to the 3rd power. And that would be all you need to do there. We have time for the PSAT. Go ahead and stop it, try this one. Semicircle to the right, centers at 4, 0. I see that, which defines x coordinates whose y coordinates are equal. So one, if you kind of just chart this out, this is 2, this is 1 approximately, this is 3, this is about 6, 5, 7, and 8 there. So 1 and 6 are not really symmetric with the center. I don't think that's going to work out. 1 and 8. 1 and 8 are not, because that's right on the end point, and that's not it. 2 and 6 are very symmetric. So if you follow that point up, it's going to be right there. Follow this point up, it's going to be right there. Those should be directly across from each other because the center is right in the middle between the two. It's like 2 and 6 are symmetric, 1 and 7, 3 and 5, 0 and 8. Any of those will work. So this one would be the correct answer there.